looking at lesson 116 today? A little bit. Yep. All right, we're looking at fundamental counting principle and permutations, and then we're going to look at probability and independent events. You'll do a lot of this in pre-cal, and in college, if you like probability, you can take a whole class on probability. I like it. Probability is really easy. It was a really, really easy class. Once you get the hang of it. It takes a little bit to get the hang of it, but once you got it, it's really, really simple. If you've ever heard of someone that, or if you've ever heard of people that play poker and they're like, oh, you know, that's only like 1 in a million chance of hitting that kind of hand or whatever, that's what they're dealing with, probability. So we're not going to go that in depth, but if you take a class on it in college, most of your homework is what are the odds of getting a full house? What are the odds of getting a straight? What are the odds of getting a royal flush? What are the odds of getting 4 of a kind? That kind of thing. Yeah, I mean, that was most of my homework in probability. So, all right, we want to start by arranging the letters A, B, and C in our boxes in as many different ways as possible. So, on your paper, write down all of the ways that you can rearrange A, B, and C. Whoever gets the most wins. You don't win anything, but you just win. Yeah.
I've never known
We'll go over it.
if we go over like every year since the 3rd grade, I'm still get it.
Is AAA a possibility? AAA a possibility? No. You're rearranging A, B, and C. Okay.
You can screw up the whole thing.
No.
Justice?
That was the actual
No.
possibility of it.
I wouldn't make y'all write that many down. So it'd be 27 if you could do that. Okay. How many did you get, Jamar? What about you, Destiny? Sarah? Jason?
I don't think that's right, because like everybody else said 6 days.
6? How many did you get?
I get it.
How many do you have?
I'm in 3 right now.
Okay, keep going. Someone go write one of them. And we'll see if it is 6 or not.
You're right, ABC.
Okay, ABC. Someone go write another one.
Okay, I got it.
You did? Okay. Go ahead and get ready. Yep. 6 of y'all are going to have to go up there to write them. Go. You said to your mark. Okay.
I just realized I looked at it.
Genius.
Wait, now I got 7. That's not right. I think I did one twice.
Yeah, she did one twice.
That means 6 is the right.
All right. The other two?
And it, like every person, like everywhere you meet your eyes, they were like, I found the wrong one.
Yeah, you can roll her.
Someone else?
Still feel your brain. Feel like she's
Hey, there's one left.
Somebody else has to write it. Okay, do you agree? All right, so how did I know that there were 6? No. How many letters do we have to choose from? All right, so we can put any of the 3 in that box, right? After we pick one, how many do we have left? So we pick one of those, and what do we have left? 27. Yeah, and if it was 3, 3 factorial.
Use the and one, you can remove the calculator.
Yeah, it's a button on the calculator. If you could use AAA, then you could pick A, or you could pick A, or you could pick A again. You could pick any of the 3 every time. You would get the 27. That's how I knew it was 27. And that's why I would not make y'all write those. Does that make sense? Okay, we're going to do some more.
This was what easy. Oh, yes.
So those are all the ways that you can arrange them. We don't have to go over that because you already got it. Okay, so what is a permutation? I think I've talked about permutation and combination very briefly in a math knowledge question, but it's when, do what? Yes, not much, but it's when all of your arrangements use the same symbols, but the order of the symbols is different. Yeah, it probably has been on the ACT. So what we did just a minute ago, we looked at all of the permutations of ABC. We're still on lesson 116.
16 is really long. I was looking at it earlier. Like, there's like 4.
We've got until 3 o'clock.
I think I'm not getting softball out.
Nope.
I really did.
You're not
Maybe
leaving
that
go.
excuse to stop.
You're not even
But it would be long though. Like, right.
So, your permutations, the order makes a difference.
The laugh is the way you go. Yeah.
Alright, so this is the fundamental counting principle. Write it first, and then I'll go over it.
So we're learning 2 lessons.
So, if one choice can be made in A ways and another choice can be made in B ways, the possible ways to make all of those is multiplying them together. Alright, I want to pick, in this classroom, I want to pick one girl student and one boy student. Yeah, not literally. I want to know how many different combinations I can make. Well, how many girls are there? So how many girls can you pick? Okay, 7. Sure, that's fine. Or 6 if you want to go with 6. I don't care. It's just a demonstration. How many boys can you pick? So those are the A ways, and those are the B ways. When you multiply them, we can make 28 different one male, one female combinations. Does that make sense? If you don't believe me, you can write them all out. They're only 28. Yes, I was just about to say, do you remember doing these things?
I never got
Do y'all remember doing those like in elementary school to figure out How many different combinations of outfits can this person wear if they have 3 pairs of pants, 2 shirts, a belt, and 3 hair ponytail things? Well, yeah. So now you don't have to use a tree. You can do it a different way. Well, we're not going to predict the number of ways to place the letters A, B, and C in the 3 boxes because you already did it, right? No, you don't have to. Okay, so how many ways can we arrange them? If letters may be repeated.
27.
Why is it 27?
You told us that.
But why is that true? You can put any of the 3 in the first spot. How many can you put in the second block? And then in the third block? Letters may be repeated. So after you put all 3 of them there, well, you still have all 3 of them to put here and then in there. Does that make sense? Because you can use the same letter over again. Okay, so how many different ways can the numbers 3, 5, 7, and 8 be arranged if no repetition is permitted? No, don't do anything. I'm going to show you what to do. All right, how many numbers are we looking at? So how many options can go in this first block? All right, repetition is allowed or not allowed? So after I pick 1, how many do I have left? I've got 3 to go here, and then here. And do I add these numbers? I can pull out my notebook. I don't remember.
Let's not do that. We don't want to burden me.
I mean, I don't remember.
All
Alright, how many 4-letter signs can be made from the letters in the word equal if repetition is permitted?
Wait, was that 5?
All better signs.
550 pounds, yeah. It's like,
We're not there yet. Alright, so how many blocks are we going to create? Why only 4? We use 4 at a time, right?
Yes.
Y'all with me so far?
wow, they're fun.
Okay, how many letters do we have? How many can go in this first spot? And then now? Why not 4? Okay. So what is it? Because it says 4-letter signs. Only wants 4 at a time. Does that make sense? Go with me still? Okay. Alright. Don't say this one out loud. Try and do it by yourself.
I draw a box every time.
How many boxes am I going to draw?
You have 8 questions.
Okay, why am I 8 boxes instead of 4 boxes? There are 8 questions. How many answers do you have for this one? You have 4 options here. What about here?
5,536.
Me too. Did that so well.
So, how likely are you to guess the right answer
Not very likely.
on all 8 of them? If you don't know what you're
I'm gonna
doing,
guess it.
the likelihood of getting all 8 of them right just by guessing is 1 out of all of that. Okay. All right. Try this one by yourself. Okay, how many boxes are you going to have? 1, 3, 1, 7.
7.
How many 3-letter signs? So we're picking 3 at a time. All right. How many letters do we have in total? So how many can go here? Why 6 and not 7? Okay. Which is? Any questions on these so far? Okay. One more? I think one more. Yeah.
So if it doesn't say no repetition.
I'll let you think about it yourself. Think about it logically. I'll put it that way. Think about if it ever says items. Think about people. I want to rearrange these people. Can Molly go in 2 places? Can Molly go into 2 places?
Well, technically.
So 1 foot in this place and 1 foot in this
Yeah,
place.
there's a corner. Like, there's like a big space. They always say watching.
And you can get rid of all 4.
So what if you like? What would you do?
Like smoke.
What'd y'all get?
I got 79 times 35.
No.
I got 6023340.
Yes.
60,233,040.
Yes.
Yes.
Wait, what?
Yes.
How did we do that?
38, 37.
You have 5 foot wide.
Wait, you don't know that? Oh, it's me. Yeah.
Okay, why do I have 5 boxes?
She only has 5 feet.
5 places to put something. I can put 38 in this spot. Can you repeat items? If I have my 4 markers and I want to rearrange them, if I put the black one, can I put the black one somewhere else? Once I put the black one, I only have 3 markers left. Does that make sense? Whoops.
I love that like that she had a paper.
Yeah.
I would read like rip it off.
Yeah.
Or pull the computer off the table.
Yeah. Well, I've done it enough that I know now. I can't leave.
I can see her accidentally screwed up one time and she did all the day.
No, it would come out pretty easily. All right, so for probability, each outcome has to have an equal chance of occurring. So whenever we look at like rolling a die or rolling 2 dice, it's always going to be a fair die or 2 fair dice. Y'all know the difference between die and dice? Die is singular, dice is plural. Kind of like mouse and mice.
I know you can get trouble rolling dice.
You can?
Yeah,
Like I mean like rolling dice.
yeah.
Oh, okay. I thought you did like just like yeah, it's gambling.
Yep.
How do you do that?
Like whatever number to land on.
Yeah.
Each equally probable outcome is called an event. The set of all of your possible outcomes is called your sample space. The probability for a particular result is the number of outcomes that are...
Miss Justice,
Yes,
you have Sean Tillman
I do.
from the Hall Pet Center for the Field House to report to Coach Robinson.
He's in math class for a lesson.
Ma'am?
He's in math class with a lesson.
Okay, repeat that one more time, Miss Justice. I'm not making out what you're saying.
We're in math class. We're having a lesson.
Okay, I'm still not making out what you're saying. I'm so sorry. Are you saying he's not in class for a lesson?
He's
No.
in math class for a lesson.
Okay, so he can't make it to the field house.
Yes.
Well, we're doing a lesson right now, so not exactly.
Oh, okay, I'll let him know he can't make it. Thank you.
Miss Ivy.
Miss Ivy.
She is like FBI agent.
All right. All right, so the probability is the number of possible outcomes for whatever you're looking for out of the total outcomes. The number of your outcomes out of the total number of outcomes. So we're going to look at dice and coins. And I don't know that we'll get the cards this year. I know they do them as... I know that we do them your junior year, but I don't know that they do cards this year. We'll get there, yeah. No. You don't include jokers in probability. You don't ever play with jokers in... Whoever gambles with Go Fish.
If you play Battleship.
Who gambles in Battleship?
I play War. I'm going to win this battle.
All right, moving on. Yeah.
Yeah. Joker's would be like a lot.
We just always play that. Yeah, I've always played the default game.
All right, so in a coin toss, let's think about a coin here. Are there two sides?
Yes.
So how many different options are there? Your total possibility. You can do two, right? Okay. How many ways can you roll a head? 1 out of 2, right? You have a 50% chance of hitting a head. What about a tail? We leave them as fractions. They don't ever put them as decimals or as percentages. But 1 out of 2, 1 out of 2 for both, right? When you flip a coin, you're either going to get a head or a tail, correct? There is no other option. No. Right? Do you agree? Your total should always add up to 1. You can never have a probability greater than 1. If it's 1, that means it's guaranteed to happen. So if I said, probability of landing a heads or a tail with 1 coin is what? Is 1, because you're either going to roll a head, you're going to flip either a head or a tail, right? Okay, what about for a single dice, or die? How many options are there for a die?
6.
Why 6? Okay, so rolling a 3. There's only one side that has a 3? Okay, what about an even number? How many options do we have total? How many are even numbers? So what does that reduce to? Okay. Roll in a number greater than 3.
3 or the one out.
Why 3? 4, 5, and 6. Y'all with me? Not too bad, right? Okay. 2 dice are rolled. What is the probability of getting a 7 and a number greater than 8? Well, first we want to make our little chart. When you roll 2 dice, how do you figure out what you rolled? You add them together. So if you roll a 1 and a 1, what is your sum? What goes here? You might want to be making this one on your paper because you're going to need it.
We had one of these charts.
You have to make it yourself every time. Yeah, you cannot take a chart with you to the test. You need to know how to make it. If you can't make this, maybe you don't need to be. Maybe you don't need to be in gifted if you can't add your numbers correctly. Because that's all you're doing here. That's it. You're adding.
She goes to I mean, honestly, what? Like, they really do every year, like, I don't know,
Do you agree with my chart?
Is
Scholars banquet.
Scholars banquet?
Scholars banquet. There it is. Word.
all the things that you
Yeah. She always does it.
All right, so what's the probability of getting a 7? Well, first, what is our total possibilities? Okay, 36. How many are 7s? So 6 out of 36? Miranda says it's 1/6. Do you agree? Okay. What about a number greater than 8? Well, how many options do we have in total? Okay, which ones are greater than 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So don't leave it like that? Do y'all see how that works? Any questions there? Okay. So, independent events. If I roll a dice and I flip a coin, do those affect each other? If I roll a dice and I flip a coin, like, does whatever I flip over here affect what I rolled on the dice? Those are independent events, right? So they're events that do not affect each other. So the probability of independent events occurring is the product of the two probabilities. So if you want to know what's the probability of rolling a 3 and flipping a head, then you would find the probability of this one, find the probability of that one, and multiply them together. Yes. You can use tree diagrams if you want. We'll go over the tree diagrams for one. If you want to use tree diagrams, you can use them. You do not have to.
She said, this like roll the die and the coin flip. And he said, this is a line with the sun. I keep thinking about it. He said like, he was saying like, this is a line with the sun, like straight face. I can see the face in my head.
All right. So, this is our tree diagram. In our first toss, we're looking at a coin. What are the options? Flipping a coin. Heads and tails, right? What about your second toss? What are your options? So when if you flip a head, you could hit either a head or a tail, or if you hit a tail, you can hit a head or a tail, right? Okay, what about for the third toss? Heads and tails every time. And you can actually draw it out. Like I can get this and this. You have to do the tree diagram.
Teacher, probably interruption. Would you please allow all girls softball players to report to softball field? Thank you.
Alright, so you don't have to use the tree diagram. We're going to look at it without the tree diagram. How many ways can you flip it this way? I mean, like, what are your options? You can do either a head or a tail, right? The second time, what can you do? And the third time? Which is a total of 8. You have 8 different ways that you can flip it whenever you flip it 3 times. Which is how many you get over here. 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? Y'all with me? Do what? What? Because you were talking? Y'all are talking?
He's talking about I can't do that.
So, if you have 8 options, what's the likelihood of head, head, head? What's the likelihood of hitting a head, a head, a head? We have 8. You have 1/2, 1/2, 1/2. What do you do to those to get the 1/8? What about a head, a tail, and then a head? Like in that order. Why? Okay. Alright, so fair coin is tossed 3 times. What's the probability that it comes up heads every time? How'd you do that? Okay. Fair coin is tossed 4 times and comes up head each time. What is the probability it will come up heads on the next toss?
1/3. Oh, 1/2. Ha ha. 1/2. You don't think about the other.
Doesn't matter.
Alright, I flip it, I flip it, I flip it, I flip it. Okay, I flip it. What's the probability of getting a heads? 1/2. Did it care about the other 4? No, it doesn't. No, it doesn't. No, it doesn't. No.